Awesome. All right. Well, I'll go ahead and kick it off then. So, my name is Jonathan Crow. I say, obviously, you guys don't recognize me, but I work over here at FRC East. Our initiative is Imagining Tomorrow. This is basically kind of pushing you guys, to what things can you create, what things can you push us for, and towards, let's say, in the future. So I'm going to switch over here. It's maybe a little blurry for you guys, but I don't know if you can see this. This is the latest fighter jet that we have. I say this is the F-35 Lightning II. I say this is Marina Bay Sands in Singapore, one of the latest and greatest architectural feats that we've made this century. And I say this is the Tesla Cybertruck. I'm sure you guys have all seen that. Again, pushing the limits of technology and what we can do. Again, my name is Jonathan Crow. Happy to be speaking with you guys today for E-Week. A little more about me. I say I'm a mechanical engineer. I will go into that a little bit more of what a mechanical engineer does. I work for Fleet Readiness Center East, and then that is on Cherry Point Marine Base, which I'm sure you all are very aware of. I work on MQ-8 UAV aircraft, and the reason why I say UAV is, I don't know if you guys can see the pictures, but these windows are painted over. There's actually no pilot in either of these vehicles. So these vehicles are UAVs, which what does UAV stand for? It stands for Unmanned Aerial Vehicle. So these aircraft will actually be controlled with a control station. You'll see these guys actually using Joy-Cons and stuff that you guys are actually familiar with in like video games or whatever. It's a very similar concept. A UAV is basically put into two categories. It's either autonomous or it's a drone. You guys, I'm sure, know what drones are. You guys have probably maybe even flown them. You can buy them readily at the store. RC drones, but basically it means that there's user input. Autonomous, which is actually what the aircraft I work on, means that the aircraft does not actually take user input. The aircraft is simply logged in to go to a certain location, and it runs its own sequence of code that basically gets it there. So that's actually kind of like the next step in technology, where you actually are limiting the amount of error that a pilot would induce by just running computer program. All right. So now, what is engineering? Engineering is the application of science and math to solve problems. But now, what problems? Because problems like back in the day are obviously different from problems that you guys will face. Problems you guys will face are solar energy. It's a hot topic. It is a huge thing in engineering. When you get into college, it will be pushed down your throats. It's kind of the next leading thing. But the big thing about that is affordability. Solar energy does produce energy, and it's helpful for the environment, but it's very expensive right now. The government generally has to subsidize it. An alternate energy source is nuclear. Because we're really trying to get away from coal and oil, very dirty burning, energy sources. We're trying to get away from them. Another struggle that you guys will have to do is engineering clean water sources. There are third world countries out there that don't have access to water still. And on the same topic as that is improving and restoring city infrastructure. More people are being born every day, and they're moving to the cities, and new cities are being built. And you're going to have to work on buildings and infrastructure to support those moves and those people. Engineering better medicines. Again, Moderna vaccine is something that you guys are very aware of. It's happening every day. That vaccine was engineered within a year. Again, one of the great feats of our time that we were able to go through engineering, designing, and actually outputting a vaccine within a year. Internet and cyberspace, something that people don't talk about as much, especially here at the Navy, is a huge concern of ours. Hence why we're kind of going through this like I'm presenting to you, because I can't even get onto your guys's like Zoom meeting with my work computer because we're worried about basically people hacking us and getting our information and within the stream. And it's a very wealthy and a very prosperous market for computer engineers, electrical engineers, coders. Is a growing field, and we definitely need them at the Navy. Virtual reality, and again, I'm sure you guys have used this. It can be used anything from medicine to helping doctors basically like see the operation before it actually happens. Being able to help pilots run scenarios just like they're in the cabin. So all of these are problems that you guys are going to have to engineer and tackle, let's say, over the coming years. So I said I was a mechanical engineer. Mechanical engineers design mechanical systems. That's very specific. So it's basically things like gears and structural analysis. This is called finite element analysis. It's basically saying the force of the wind acting on these red spots is greater than the cold spots. So it's saying that there's actually more force, as we would think, right here in the front, where all the wind is getting pushed against this wall dam in the front, versus after it's already cleared the car and it's now breaking over, there's less force being put right here on the roof. So, and you can see this too in this where they do a wind tunnel test. You can see the flow of the wind across the car. Again, this structural analysis stuff is all part of mechanical engineering. This is a Bugatti Veyron engine, W16 engine. Really, forefront of engineering as far as supercars. The new Mars rover, mechanical engineers would run analysis on how much force each one of these particular parts are occurring during or in Mars gravity. So this is if you're into mechanical stuff, you like seeing things mechanically, and you like touching things with your hands. Like this is the engineering field for you. If you like working in chemistry and you like chemical compounds, we have chemical engineering. Develop processes to turn raw materials into useful products. Shameless plug for Stephanie Kolik. I say the designer of actually she invented the compound that gave us Kevlar. Kevlar is used anything from the structural piece of tire to bulletproof vests to you actually the nose cone of the jets are Kevlar. Was a huge contributor to science. Electrical engineering. I say the actual people who so it's funny because this picture I saw on some of the presentations people had given. This was on the mechanical engineering side, and while building of the cars and while car manufacturing is generally considered mechanical engineering field, electrical engineers are actually the ones who make the robots move and program the robots to then build the cars. So it's very multifaceted in any one of these industries. Avionics for all of our aircraft are all studied by electrical engineers. How much current each part of the aircraft is getting, making sure that we aren't shorting something out and creating damages. Like the heads-up displays for the pilots in the F-35s. All of that's all electrical engineering driven. Say civil engineering. I say tallest tower in the world. Say Dubai. Burj Khalifa, I think is what the name of it is. Again, tallest tower in the world. Hoover Dam, considered one of the largest dams in the world. It's kind of down there on the list now. Your main job as a civil engineer is going to be design and maintain public works. This can range anything from roads to dams to sewage ways, again, to buildings. It's very construction based. So your J will generally be at a construction site. I get very hands on, but there's a lot of parts to this one. So I say if you're engineering, if you're interested in this type of engineering, say it's civil. Agricultural engineering. I knew this one would kind of hit home with you guys. I'm from a very small town. A lot of my friends actually went into agricultural engineering. This is like GPS guided tractor. So they actually do a farm map where they basically map out the perimeter of the farm, and then a GPS unit on top of the tractor will actually follow that pathway. And what it does is it minimizes the loss of crop between the so like normally if you ran your plow and then not your plow but your I'm thinking of harvester, you ran the harvester, and if you missed a row, whatever, you would have to spend gas to come back and do that row. Whereas this basically minimizes that loss. It gets it so that you are doing the exact rows fit to the length of your harvester, and saving, like I said, farmers gas, doing it more efficiently. Maybe there's a different direction that you should be going to do your field. It would maybe make it be harvested quicker. The amount of water that you're using to harvest your field, and the adequate, adequate water consumption for your crops. Again, agricultural engineering. You can see they're actually using drones now to spray insecticides on crops. So it's a very exciting. A lot of people don't think of this one. It's kind of one of the engineerings that are kind of on the bottom of the list for some people, I'll say. But I mean, people got to eat. It's a very growing field. So aerospace engineering. This one is if you guys are really interested in joining FRC East, this is probably the highest. I want to say highest. There's the most of these, the most degree within our workspace, because we deal with airplanes, because we deal with helicopters. Aerospace engineering, it revolves around improvement of aircraft and spacecraft. I wanted to be an aerospace engineer initially. I decided to be mechanical because mechanical is a larger umbrella where you can do aircraft, but you can also do cars, or you can also work on bikes, or it's multifaceted. So if you're really interested in rockets or aircraft or that kind of thing, aerospace engineering is definitely for you. And this is actually offered in the Craven 2 and 2. A little bit, few years down the road for you guys, but like I said, that's how a lot of people have gotten their degrees in this area. Other types of engineering, again, you see, this isn't even this is probably half of the engineering degrees that you can get. So there's nuclear, biomedical, computer, industrial, mining, aeronautical, mechatronics, and welding. Again, an example of welding engineering, Rogue Fitness. I don't know if you guys are familiar with that. They use a welding technique called friction welding, and that's actually how they adhere their collars to the actual lifting bars. They were one of the first in the industry to do it. They spin it up on a lathe and actually get the metal so hot that it actually melts to one another. The new aircraft carriers that we just purchased, all nuclear ran. Actually, a nuclear reactor is actually what actually powers the turbines. So, tons of engineering options. You don't have to, if you say, oh, I'm not really interested in cars or airplanes, I guarantee you there's an engineering. If you guys are interested in STEM, if you guys are interested in logical thinking, there's an engineering for you. So this is just at FRCs. This is some of the platforms that we actually support. We are considered the vertical lift center of excellence, meaning that we are a center of excellence for helicopters and the repair of helicopters and the improvement and the research and basically how to actually make them better than they were. So we support anything from AV-8, H-1. It's in every 1970s movie you've ever seen. I say RQ-21, again, another drone aircraft. F-35, our latest and greatest. BH-92, I say presidential helicopter. C-130 is our cargo plane. Multitude of aircraft here at FRC East, and plenty of platforms. Let's say to pique your guys' interest. I wanted to reach out if you guys had any questions. I just wanted to take a brief pause, kind of before we went into the activity. I say feel free if you guys have any.
I have a question. How many engineers are there at FRC East? Do you know?
Yeah, so say right around 1,000 actually. Oh. I say, and again, those range anything from chemical engineers to mechanical engineers, electrical engineers. Like I said, we're very multifaceted in that regard.
Very cool.
With the majority being aerospace, mechanical, or electrical.
Yep.
What's by number 2 after aerospace and mechanical?
Yep. Yeah. So aerospace and mechanical definitely are number one. Like I said, then I know a lot of our planes use, you know, extensive avionics. So I say electrical is going to be number 2.
Any questions from students? You guys are welcome to unmute. Or if you're in the classroom, you can just tell me. No question? How many different, or how many planes are y'all, and you may not know this off the top of your head, but how many can you service at FRC East kind of at the same time? Or how many are on going through being
Do you mean
serviced?
the different platforms or how many fit in the hangars?
Yeah, like in the, between all the,
Comes from the trees.
Trying to think, we have 4 hangars.
I think so.
Yeah, because we have F-35 hangar, heavy lift hangar, V-22 hangar, and then so there's a 4th one. And I'm thinking there's 15, 20 aircraft in each hangar.
Wow. Probably close
Yeah.
because there's 2 rows.
Yeah, so I think we're,
Depending on what they are, yeah.
I think I'd say 60 to 80 aircraft at a time.
And that's actually in the garage.
Yeah. That's in the hangars. Like, and we have other aircraft to say that are actually, you know, actually on the grounds, basically being ready for service.
cool. Cool.
But the other thing too to mention is that, so I actually have worked here about 2.5 years at FRC East, and I'll actually be transferring to another, base that we have actually in our network. So, you know, the network that we have, we work for is NavAir, and we have NavAir Mid-Atlantic, which is up there in Norfolk. We have NavAir PAX up in Maryland, NavAir, Southwest, which is San Diego, and Point Mugu, which is above Los Angeles. You know, all of these, you know, different NavAir locations, say service naval aircraft. So if you guys are wanting to travel and, you know, kind of get to a different location, we do have other options for that as well.
Cool. Well, that is wonderful. All right.
Well, so we
If
can
anybody-
transition into the activity.
All right. Let me, if you want to go ahead, I have not had the opportunity to really tell the students at home, but you guys will need a piece of paper. And I think I did put it on the playlist. I think we talked about it yesterday, but you need a piece of paper for today and like a paper clip if you have one, preferably, or something small like that if you don't have a paper clip, something small and little. So I'm going to get everybody in the classroom ready real fast. All 4 of them. All right.
I say I'm just using blank sheet of paper, and then I got my paper clip. So it's all.
Well, did you want to get started first before we pass that out and just kind of explain?
Oh,
Yeah.
yes, yeah,
Yeah.
You're right. Yep.
I'll give you guys a paper clip. I will do that. All right.
So I'm sure you guys have seen this before. So this is the scientific method. I say it's 6 steps. I say first of being asking a question, second formulating a hypothesis, then designing an experiment, then logical reasoning, then testing of a hypothesis, and then finally formulating your theory. So this activity is going to basically we're going to start with this. So this we're going to follow this as we're doing the activity, and then I'll start with the question. So one of these activities, how can we transport this paperclip about 10 feet from you? So about 10 steps, you know, away from your desk, you know, basically just kind of across the room, if you will. So about 10 steps. you know, obviously I know you guys don't have tape measures or anything. So about 10 of your feet, you know, heel to toe. The question is how are we going to transport this?
All right.
So I want basically kind of everybody to kind of think in their minds a method. Just give you guys some examples. Just again, I know you guys are thinking about some, but throwing the paper clip. Can you throw the paper clip 10 feet? I don't know. We'll find out. So once you guys kind of have that in your mind, all right, we're going to design an experiment. So what that means is we're going to have to test this. We're going to have to measure out 10 feet. We're going to have to get enough space to obviously do the experiment safely. And then right before we do the experiment, we're going to use something called logical reasoning. We're going to say, what do we believe the outcome will be based on past, experiments we've done, experiences we've had, kind of taking all of that knowledge that we have and then, really thinking about what the outcome is going to be. It's called a conjecture, is what we're going to do. We're going to form a conjecture before we do the experiment. Number 5 is going to be testing the experiment. So if you guys want to, I don't know if you guys want to do it in the classroom or not, or at home, but if you guys want to go ahead and test, how far you think you can throw the paper clip. You throw it the 10 feet that we required in the beginning.
All right.
So.
Do you guys think that you can do it? Do you have any other ideas other than throwing? Oh, like a catapulting it? Okay. Say that again. Oh, ejecting it using your mouth. That's what.
There you go.
Hitting it like a giant watermelon seed. All right.
In time of COVID.
I got one. He said drop kicking. Drop kicking. That might be interesting. Any ideas from anybody that's at home? You're welcome to unmute. How could you transport a paper clip? What if you couldn't use your body? Any ideas?
At home, use a Nerf gun.
Say that again. I'm sorry, I didn't hear you.
At home, you could load the paperclip into a Nerf gun.
Ooh, I like that. Maybe or tape it around the part of the bullet. What do you think, Jeff? Ooh, Jonah said he could fly it on an airplane. That's an idea. Any other good ideas?
Make a catapult out of pump.
All right. We could make a catapult out of popsicle sticks. Those are all some great ideas. Any others?
See how well it would work if you used a fan.
If you put it on a fan?
Well, if you put it in front of a fan, depending on how it would spin, maybe it could.
Okay, I gotcha.
I thought of putting it on the
We have somebody trying it on the little plastic helicopters. It
There
did
you
not
go.
did not work well. All right.
All right, guys. I mean, again, like I said, throw it was just kind of like kind of the start. Like I said, I was really kind of wanting you guys, like you guys were doing, to think about other ideas. I think someone even said flick. Flick was kind of my secondary idea. But now after we test it, we're going to basically form a theory. We're going to say, was it possible to get it to 10 feet? And then kind of think about a conclusion of what could I have done differently? What could I, if given these same exact scenarios, what could I have done differently? But the real meat of the activity that we're going to do is we're going to restart it. We're going to take the same paper clip. This time, I'm going to give you guys a constraint. You guys have to use a piece of paper to do it. So,
doesn't have to be a fancy piece of paper. You can just go grab a piece of notebook paper and see if you can come up with a way to get your paper clip across the room from where you're at. So most rooms are around 10 feet or so. Will it work? We've got some good ideas. All right, each of the tiles on this floor is 1 foot. You can count to see if you made it 10 feet, but. All right, wait. Let's hold that thought and let's let Mr. Crew continue.
All right, so we have the question. We have the how can we transport the paper clip with a piece of paper 10 feet? So that's our question. So now we have the hypothesis. So this is where we're formulating these ideas. We're using what we just did, we're taking those outcomes of our last experiment, and now we're formulating a hypothesis of how we're going to basically do this experiment, or what method we're going to basically test this experiment. So same thing, 10 feet, measure out is what we're going to be. We have our paper, we have our paper clip. And now we're going to do logical reasoning. Take your idea, think about it, think what will the outcome be if I use this method, basically, based on what we just saw and I say with the last experiment. And then I say we're gonna go ahead and test that. I say if you guys we want to go ahead and put your methods into practice.
All right.
My crumbling art paper is
Oh, so one of my students just tested it and he crumpled it up and put it inside, but he said that it didn't work because the paper clip fell out.
I'm gonna
So-
try attaching the paper to the paper this time.
Okay. What kind of tools are you needing? Huh?
This time it'll work.
Well, that's an interesting idea there, PJ, but remember our constraint is all we're allowed to use is a piece of paper. So sensors, I liked
I
Jonah's
attached it
idea.
to the paper this time.
Ah, you improved your design. That definitely worked better.
Last time I was worried about crushing the paper clip.
Ooh, that worked. Did it fall off? I heard something. All right, I'm gonna let Logan and Jonah come here because they're testing right now, and I'm gonna let them share with you guys what they've found out. Logan, I'll let you share first. Let me unpin for just a second. Let me go to my view. Release. Oh, gallery. Hold on just a second. Remove spotlight for just a minute. Okay, so if everybody can see, here's Logan. Logan, share what you did first and what worked better.
First time what I did was I just set the paper clip in the center of the paper and crumbled it up and threw it. It fell out, went 2 feet in the opposite direction. So I decided I was going to put the paper clip on the paper and then crumble it up, and it is staying.
Yeah,
Using
so
how a paper clip should be used. Ish.
cool. One thing I noticed the first time you threw it, the paper didn't go very far, but the second time the paper went a lot further.
Because the first time I was worried about bending the paper clip.
So you just had it really lightly
Yeah.
folded? Okay. All right, Jonah?
Don't care.
I made a paper airplane, and at first I just put it in the middle of it right here, and it fell out. So like Logan, I had the idea of actually using the paper clip and clipping it onto the paper, and it doesn't fall out as easily now.
Did everybody hear that? Everybody hear Jonah? So they did have better success. Did anybody, if you're at home, did anybody find a way that was successful that you'd like to share? My home people are kind of quiet today.
I'm getting my ears.
All right.
I mean, mine.
All right, go ahead and,
Isn't this in the hallway?
All right, Logan, PJ, and Jonah, have a seat for just a second.
Guys, say, well, I applaud your guys' ingenuity. I started with the airplane as well. Again, it was good on you guys for discovering that you kind of have to secure the paperclip. I mean, it will fall out during flight if you don't like you guys were saying, kind of attaching it there to the inner part of the fuselage there before you throw it. So good on you guys for discovering that. I say after your first attempt. Again, another option, like you guys were saying. Here, I'll switch the screens because now we're coming to the conclusion. We're formulating our theory of what works better and kind of how we can maybe improve our designs next time. I also tried the crumpled up paper. I was really glad to see that you guys came up with two different methods. The third method that I'll show you guys is, how about this? So this is an origami star. And guess what? I used this much less paper. So I used less materials for that. So the whole point I want you guys to think about is you've asked yourself these two questions after the experiment. Did my method solve the problem? Was I able to transport the paperclip the 10 feet? And did I stay within my constraints? Did I use one piece of paper? Did I accomplish, basically crumpling this piece of paper or building this airplane within my time constraints, which you guys all did. Again, amount of materials, I didn't throw that constraint in there, but it ended up, as an engineer, you had that in the back of your mind of how can I use less materials to build the project. So now to tie in to the Mars rover, I wanted to show you guys this. So you guys have seen the Perseverance rover. I don't know if you guys know how it landed though on the surface. It used something called a sky crane, and after it parachuted in, a smaller piece of it was released, and then used thrusters to hover above the Mars surface, and then it actually lowered the rover onto the surface. This was actually a new method. The old method, which you guys wouldn't have remembered, was the Opportunity rover back in 2004 used giant balloons. And basically the intent was after the parachute basically got it slowed down enough, and then the thrusters released, again, further, it used the same thrust method, but again, at the bottom, instead of lowering it down like a crane, it just dropped it, and the balloons actually cushioned the blow. So this is kind of to illustrate two real world scenarios where very different methods were used, but again, we got two rovers on Mars because of these different methods. So I say, engineering is about, kind of opening your mind to other possibilities of a solution. I did want to end on this, just I say, because you guys might be interested in this. We have at FRC something called a Fab Lab, and it's available to all students and teachers, I say, if they want to kind of create a lesson plan off of it. It is free of charge, but I say it basically would allow you guys to use 3D printers, vacuum forming, and other engineering things that we use here at FRCEs. So anyway, if you guys are interested in that, I say just let us know. But any more questions? If you guys have any questions from even the start of the presentation to now, I say please feel free to ask.
Well, I think you did a great job. I appreciate so much you coming and joining us today. Does anybody have any questions that you would like to ask, or anything that you want to share?
Yeah, I think where you feel comfortable.
Huh? Oh, PJ said he had a question and he forgot it. That happens.
Yeah, don't feel bad. It happens to us all.
Yeah. Well. All right. So PJ does have a question. He said, is there any field of engineering that goes along with the body? Is that correct?
Oh, That's a very good question, and there is most definitely. I say biomedical engineering is probably the largest, but there's also biomechanical engineering. Biomedical engineering focuses basically on the improvement of biomedics biology of the body. So you are engineering new methods to create alternate or artificial tissue, things like that. Like I said, but there's also biomechanics where you're actually studying kind of how the body moves. Two very popular fields. Actually, my advisor in college actually was a biomechanical engineer, and he does a lot of research in that field. Yes, that is very available to you, and it is a great field. If you like medical and you like engineering, that is a great mashup of the two.
Excellent.
That would be me, sorry.
I was just looking down going, was that me? That is really cool. One thing I heard, and I think it's in the next, like within the next decade, 5 to 10 years or so, they've come so far with biomedical that there's a lot, they'll be able to do transplants for people that are very sick, waiting on different organ transplants, using, instead of having to wait for somebody to pass away and donate their organs, they'll be able to actually create those in a lab so that somebody who needs them can get them sooner, saving a lot of people's lives.
Definitely, yeah. They're 3D printing it now isn't just being used in industry. Even in the biomedical field, it's being used to actually
For the scaffolding.
yes, yep. And I say they're actually printing bone pieces and everything too, with organic material. Again, printing tissue, that kind of things, actually with 3D printers. So say it's amazing field, and it's grown significantly too. I say with the 3D printing becoming so popular.
Yeah. Well, that is awesome. Any other good questions? All right. I appreciate very much you guys arranging this visit and coming and joining us. I think it's a special treat. I know the kids probably get tired of hearing my voice every day, so just to have somebody coming in is a wonderful treat. All right, and I'm recording this, so just so you know, I'll be sharing this with my other classes as well, and that'll be great.
Awesome. Well, I say, and if you guys have any questions, say feel free. I say the Alchemist Gun 3. I say you can even email me. I don't mind answering questions. So let me know.
I'll be happy to do that. All right. Well, on that note, for you guys that are at home today, I'm going to let our guests, if they would like to go ahead, they can, and I appreciate it. And then I'm going to share with you guys really quickly before you leave what I want you to do for your assignment today, so I can just clarify that. Let me get there. So in modules today, the FRC East Engineer Visit assignment, I want you to respond, and it can be in a video, so you don't have to type it if you don't want to. It could just be a video. What did you learn today? What did you do today? Be specific and complete about what you did, what you learned. You don't have to give me like 15 things that you learned, but tell me at least one thing that he talked about that you remember from Mr. Crow. And then all those different engineers he talked about, I want you to think about everything we use, everything we do has been touched by an engineer in some way. So I want you to think about how have engineers impacted your life. Maybe think of your favorite thing that engineers have done. And the last one is just a simple, like, would you want to be an engineer of any of those kinds? If you want to be specific and tell me which kind, that's great. But why or why not? Either way. That is your assignment. You can do it as a video, answering those questions, or as a text entry if you would prefer to type it rather than do a video. That is totally your choice. Any questions for me as far as that goes? All right, tomorrow your assignment is to do your scratch coding Mars quiz. And since this is being recorded, I'll just clarify that's for 6th and 7th grade. My 8th graders have a different quiz that they're doing, but everybody has the same, will have the same assignment related to this particular visit. All right, I hope you guys have a wonderful day. If you don't have any questions and you're at home, you are dismissed. If you do have